Hey guys, let's have a look at Assessment 5, which covers ratios, parts of circles, circumferences, and working with exact values, that's expressions in terms of pi. Now if you haven't done this assessment before, or it's been a while and you want to use this for practice, feel free to hit pause as we're going through the questions for the first time, and then at the end we'll take up the answers. Let's get started. So question 1 is a ratios question, different types of ratios questions, so read carefully. Question 2 is parts of a circle. Question 3 is circumference work, working with pi. Question 4 is also circumference questions, working with pi. Question 5, once again, circumference and working with pi. Question 6 is about the radius and the diameter, and read very carefully. Question 7, our last question, is a circumference problem, but it also involves area. It may help if you draw diagrams for this. Okay, so you've been through the assessment. Let's start taking up the answers. Question 1, so this ratios problem. There are different types of ratios problems involved here, so it's really important that you read carefully. A group of students go on a school trip. Number of girls on the school trip is twice the number of boys. It's always best to start a ratios problem by writing out that ratio in words. So girls and boys, and I've put them in the order as they are in the question. Note the girls were mentioned first, and then the boys after. And the girls on the trip is twice the number of boys. I don't know how many girls there are or how many boys there are, but I know the number of girls is 2 times whatever the number of boys is. So I put x for the number of boys and 2 times x for the number of girls. Now I want to write a simplified ratio for this, so I need to simplify this ratio clearly, dividing both sides of it by the same value, or in this case by the same variable. Looking at these two sides of the ratio, I can divide them both by x, which would leave me with just 2 on the girls' side and 1 on the boys' side, because x divided by itself would give us 1. So there's my simplified ratio, 2 to 1. If there are 48 students on the trip altogether, how many girls are on the trip? Okay, we started out with the ratio girls to boys, which was 2 to 1, and we were told another number. That other number was the total number. It was not a number of boys or a number of girls. It was the total number of students on the trip, which needs to be split out into boys and girls. So this is a sharing by ratios question. First thing we need to do is decide how many parts do I need to split this 42 into. And it's not into 2 parts, not equally girls and boys. There are 2 parts for the girls, 1 part for the boys. Together that makes 3 parts altogether. So we're going to split the 48 into 3 parts, and the girls get 2 parts of that, and the boys get 1 part of that. Or we could say into fractions, the girls get 2/3 of the 48, and the boys get 1/3 of the 48. So there will be 32 girls and 16 boys. Rereading that question again just to make sure that I've put the correct answer, we're asked how many girls are on the trip. So that's where hiding the ratio out in words is really helpful. I just want this side of the ratio. There are 32 girls on the trip. Question C, there is a 1 to 12 teacher to student ratio on the trip. How many teachers go on this trip? Okay, again, it's helpful to start by writing the ratio out in words. 1 to 12 relates to teachers and students in that order. So I'll write that in words, teacher to student. I'll write the ratio given, 1 to 12. And I must have been given some other value here. Remember, this is all part of a multi-part question, and in the part above we were told there were 48 students. So I know one side of the ratio, the student side of the ratio, is 48. I want to find the other side of this ratio. It's not the same ratio as above, the 1 to 12, but it is equivalent to the one above. That means whatever I did to the student side to get from 12 to 48, I need to do the teacher side as well. I multiplied the student side by 4. 12 times 4 makes 48. So I need to multiply the teacher side by 4. 1 times 4 makes 4. There were 4 teachers on this trip. Question D just asks us to go back over what we've just done. Answers A, B, or C to questions I and II. Which of the questions above was an equivalent ratios question? Well, the equivalent ratio question are the ones where you're given a ratio and you're given one side of the ratio and you're asked to complete the other side of the ratio to get that equivalent ratio question. So that's question C. And which question above was a sharing by ratio question. That's where you're given a ratio and you're given a total value that needs to be split into that ratio. Well, that was question B. There we were given the total number of students was 48 and we were splitting it into the ratio of boys and girls, or girls and boys. Next, parts of a circle. Now the way that we name the parts of the circle depends on the labeled points on the circle. So when we talk about the line from D to E, we could also call that line DE. And that's the line from here to here. And that is not going through the center. It's just a line that's cutting through the circle, but not through the center. That's a chord. The line from D to O, or we could call that the line DO or OD. That is a line that goes from the center out to any point along the circumference of the circle. We call that a radius. What about the line from E to C? So EC or CE, it's a line that cuts through the circle, but more specifically, it's going through the center point of the circle. So that's called a diameter. What do we call the curved part of the circle between D and B? So from D to B here, or it could even be the long way around, from D all the way around to B there. This would be a minor arc, the smaller one, and this would be a major arc, the bigger one. But it's not the full circumference. So it's part of the circumference. It's called an arc. What do we call the area enclosed by the lines OD and OB? OD, that's a radius, and OB, that's another radius. So enclosed by those lines and the curve between D and B and between that arc. So this slice of the pie here, what do we call a slice of the pie? The area between two radiuses and an arc. That's a sector. And what do we call the area enclosed by DE? DE is this chord. And the curve between D and E. So this area here looks kind of like the slice of an orange or a segment of an orange. It's called the segment. Next, circumference and working with pi. Here we're given the circumference of the circle is 4.8 pi centimeters, and we're asked to work out the radius. Remember that there are two formulas for a circumference. We should start with one of those formulas because we are given the circumference. We should write something equals that circumference. And I'm going to use this formula here because it's the formula that includes the radius. If we're trying to find the radius, I want the radius to be part of my formula, my equation as it's about to turn into. If I know that the circumference is 4.8, I know that 4.8 is equal to 2 pi r. And I can rearrange that to get the radius on its own by moving the 2 pi, which is multiplying by the radius, take it to the other side and divide. So 4.8 pi divided by 2 pi. I know I can divide both top and bottom by pi to cancel out the pi's. 4.8 divided by 2, that's 2.4. So r is equal to 2.4 centimeters. Next, we're told the diameter of a circle is 23.5 over pi. Work out its circumference. This time I'm going to write the circumference formula, but I'm going to use the formula that involves the diameter. So C equals pi times diameter. Knowing the diameter is 23.5 over pi, I'll just substitute that in. And I know that when I multiply pi by this fraction, when I multiply any value by a fraction, we only need to multiply the top because this is the same as pi over 1. So it would be pi times the 23.5 on the top and the 1 that I'm imagining below times the pi on the bottom, which is still say pi. So that's 23.5 pi on the top and pi on the bottom. And again, remember, to simplify this fraction, I can divide both top and bottom by pi, which would just leave me with 23.5. The circumference is 23.5 meters. Next, we have the radius of a circle, which is 14 over pi centimeters, and we want to work out the circumference. So this time I'll use the circumference formula that involves the radius, 2 pi r. Substituting the radius in there, circumference is equal to 2 times pi times the radius was 14 over pi. And again, when we multiply, any value by a fraction, we only need to multiply by the top of that fraction, because the bottom of this fraction, if it were a fraction, would be 1. So 2 pi times 14 and 1 times pi. That's 28 pi over pi. Simplifying, dividing both top and bottom by pi, the circumference would just be 28 centimeters. Radius and diameter. And notice this big warning I gave you. Why is this question worth 2 marks? A circle has a diameter of 4 meters, work out its radius. And the answer line says in centimeters. So we better work this out in centimeters. Given the diameter is 2 times a radius, and the diameter is 4 meters. So that means that 4 meters is equal to 2 times the radius in meters. Get the radius on its own, so 2 needs to move to the other side. On this side it's multiplying, that side it will be dividing. 4 divided by 2 is 2. The radius is 2. Be careful, because this whole time we've been working with the diameter in meters. So that means that our answer here is in meters. We want the radius in centimeters. So to convert from meters to centimeters, we multiply by 100. R is equal to 200 centimeters. Right, last question, and I know we have trouble with these ones. This is a circumference problem, which also involves area. A paint roller with a width of 15 centimeters, so looking at our diagram, 15 centimeters, and a diameter of 4.2 centimeters. So here I've got the circle, you can see the diameter would be 4.2 centimeters, makes a rectangular mark of paint on a wall when it completes one full rotation. As you can see here, I've got this rectangular mark of paint that it leaves behind. Just to show you how this roller makes that rectangular mark, imagine that I roll it across. And you'll see that the length of that mark is equal to the full circumference of that circle as it rolls across, which is why I've written here that the length of this line is the circumference. It's pi times d. Now to see that two-dimensionally, because right now I'm just showing you a one-dimensional line, to show you the two-dimensional area that covers when it makes that mark. Again, I'll roll that roller one rotation, and you can see that the length of that rectangular mark is the circumference of the roller, and the width of that mark is the width of the roller, which is 15 centimeters. Now work out the area of the rectangle the paint roller paints in a single full rotation. So this area here, that's going to be 15 times the circumference of the roller. So let's work out the circumference of the roller first, and then we can work out the area of that rectangle. The circumference of the roller is going to be pi times diameter. The diameter we were given was 4.2 centimeters, so that's pi times 4.2, or simply 4.2 pi. Now that's still my exact answer, and I know we're asked to give our answer to 3 significant figures, but I don't want to round it just yet because I haven't finished calculating. Let's now work out the area of this rectangle, which is length times width, so 4.2 pi times 15. And that works out to be approximately 197.9203372. I've just written the first few digits, and I generally wouldn't recommend that you do that. The only reason I've done that is to show you how I do round. To 3 significant figures, that would be 1, 2, 3 digits, and there's a 9 after that 7, so that's going to make it round up. That's going to be approximately 198 centimeters square to the nearest 3 significant figures. So 198 centimeters squared, just for that area of the rectangle that the roller makes when it does one rotation. Now a rectangular wall is 2 meters long and 1.6 meters high. Work out this area in centimeters squared. It's a lot easier to work with centimeters from the beginning than to work out your area in meters squared and then have to convert it to centimeters squared. So first let's work in centimeters. The area of the wall, which is a rectangle, so length times width, would be 2 meters times 1.6 meters. Now I don't usually write the meters into my calculation. I'm just doing this to show you why I then need to convert it to centimeters. So 2 meters times that by 100 is 200 centimeters. 1.6 meters times that by 100 is 160 centimeters. So I'm doing 200 times 160, which is 32,000 centimeters squared. So in centimeters squared, the wall area is 32,000 centimeters squared. At least how many rotations of the roller are required to paint the whole wall? Give your answer as a whole number. So we're talking about full rotations here. Well, if I've got a wall with this area, and every rotation of the roller paints this area, how many of these do I need to roll in order to fill this space? So how many of these fit into these? The number of rotations is going to be the area of the wall split into or divided by the area of each roller. And the area of each roller was the 198, so we're going to do 32,000 divided by 198, which gives us, it's approximately 161.61, and it's 61 recurring, I think. So that's going to be 161 with a 6 after it. That's going to round it up. It's going to be 162 rotations. And to be clear, they say at least how many full rotations. So 161 rotations would not cover the wall. So I would need another rotation, 162 rotations. Now, I hope you guys have found this helpful. If you still have any doubts, please don't hesitate to contact me and keep practicing.